In our last episode, we explored how concrete slabs and beams form the horizontal strength of a building. Now, we're going vertical. In this animation, from rebar to reality, building concrete columns, we break down the full step-by-step process of constructing reinforced concrete columns. From tying the rebar cage to setting up formwork, pouring the concrete, and curing for strength. Let's dive in. Columns are the vertical lifelines of a reinforced concrete structure. They carry loads from slabs and beams above down to the foundation. Think of them as the legs of a table. Without them, nothing stays upright. There are two main types: short columns, which are stocky and strong, and slender columns, which are taller and require more tension to prevent buckling. In both cases, precise construction is crucial. Let's now discuss how we construct concrete columns. Step 1. Site preparation. Before any steel or concrete appears, the site team marks the exact position of each column based on the structural drawings. This layout ensures every column lines up perfectly with beams and slabs. Accuracy here is critical. Even a few centimeters off can cause alignment problems across the whole building. Step 2. Building the rebar cage. Next comes the heart of the column, the rebar cage. Long vertical bars, called main reinforcement, carry the load, while smaller steel ties or hoops wrap around them to keep them in place and resist buckling. The spacing of these ties depends on the structural design. Too far apart and the column could fail. Too close and you waste material. Skilled workers tie these bars using binding wire, ensuring a solid cage that's ready for concrete. Step 3. Positioning the cage. Once complete, the rebar cage is lifted into position over the column layout marks. Plastic or concrete spacers are added to keep the cage centered inside the mold, maintaining a protective concrete cover that prevents corrosion over time. Step 4. Installing the formwork. Formwork is the mold that shapes the column. It must be straight, secure, and strong enough to hold wet concrete without bulging. For smaller projects, timber formwork is common. For larger or repetitive projects, steel or aluminum systems save time and can be reused. Every joint in the formwork is checked for leaks. Even a small gap can cause cement slurry to escape, weakening the column. Step 5. Pouring and compacting concrete. With the formwork ready, concrete pouring begins. The mix must match the design strength. Too weak and the column can't carry its load. Too strong and it becomes difficult to work with. Concrete is poured in layers of about half a meter, and each layer is compacted using a mechanical vibrator. This step removes trapped air, ensuring the column is dense, strong, and free from voids. Care is taken to avoid over-vibration, which can cause segregation, where heavier aggregates sink and water rises to surface. Step 6. Removing the formwork. Once the concrete reaches sufficient strength, usually after 24 to 48 hours for vertical members, the formwork is removed. What's left is a perfectly formed concrete column, ready to take its place as part of the building's structural frame. Step 7. Curing for strength. Freshly poured concrete needs moisture to gain strength. Curing is a process of keeping the column damp for several days, protecting it from drying too quickly. Without proper curing, cracks can form and the column's load-bearing capacity is reduced. What happens when columns fail? But what if a column is poorly designed, badly constructed, or neglected during curing? Failure can take many forms: vertical cracks from poor concrete compaction, diagonal shear cracks from overload, or even complete buckling in slender columns. The result? The structure above loses support. In the worst cases, this can trigger a progressive collapse, where one failure sets off a chain reaction. That's why precision at every stage, from rebar placement to concrete quality, is not just good practice, it's life safety. Columns work together with slabs and beams as one system, transferring loads down to the foundation. Every floor added to a building rests on the strength of the columns below, making them one of the most critical parts of any structure. And that's how we go from rebar to reality, building strong, reinforced concrete columns that hold our world together. If you missed our last episode on slabs and beams, check it out now to complete the picture. And don't forget to subscribe so you don't miss our next episode.